Welcome to the next lecture. In this lecture, we are going to discuss the basics of binary symmetric channel. Why we are discussing about the binary symmetric channel is this binary symmetric channel will be actually be a part of a larger communication system where the communication is done in terms of binary symbols. Let us start. The subject, the concept binary symmetric channel. Okay, let's start our analysis. Actually, the binary symmetric channel, the name itself is indicating us, it's giving some information about the concept to us. So let's analyze the name here. The first word of the name is binary. Binary here indicates that the communication is being done in terms of symbols 0 and 1. Since there are only two symbols, it is called the binary. Now the second symbol, symmetric. Here it is indicating that the probability of receiving the correct symbol, let us say it the probability of receiving the correct symbol. And the probability of receiving the wrong symbol, I, means the probability of error. So receiving the correct symbol, let it be the first probability. Probability of error, let it be the second probability. Here symmetric indicates that the probability of error toward the both ends, or the probability of receiving the correct symbol on the both ends, is same. That means, say for example, there is the transmitter and there is the receiver. Suppose I have transmitted a symbol 0. That 0 will be traveling over the free space. That will be received toward the receiver. It will be received as 0 if the noise is less, or let us say in some circumstances it may be received as 1 also due to noise. The change of symbol happens due to noise. So when 0 is transmitted but 1 is received, it is indicating us that it is error. Whenever 0 is transmitted but 0 is received, it indicates that it is correct transmission or correct reception. So there is a probability for correct to happen, there is a probability for error to happen. Let the probability for error to happen is P. So if it is taken as P, then symmetric indicates that the probability of occurrence of error where 1 is received, that means 0 is sent, is P. Then symmetricity indicates that the probability of occurrence of 0 when 1 is transmitted is also P. So error will be happening in two cases. One is 0 transmitted and 1 received. The other one is 1 transmitted and 0 received. So in both of these cases, error has happened, and the probability of occurrence of this error is same. It is equal P1 and P2. Let us assume that P1 and P2 are the probabilities of errors when 1 is received and when 0 is received respectively, i.e. that means when 0 is transmitted and 1 is received, let it be P1, where P1 is a probability of error when 1 is received, and let P2 be the probability of error when 0 is received. If P1 is equal to P2 is equal to P, both the probabilities are same, then such a channel is called as symmetric. So one we have seen what is a binary channel, the other we have seen what is a symmetric channel. So now let's go into the analysis of the binary symmetric channel. So first let me give the schematic of the binary symmetric channel. This schematic is usually having one transmitter and one receiver. So toward the transmitter, I am representing the transmitter using two dots. Here two dots is that one indicates the transmission of 0 and one indicates the transmission of 1. Toward the receiver side, so this is the receiver side, This is the transmitter side. Toward the receiver side, either 0 can be received or 1 can be received. So let us give the names of the events. Let us consider these 4 dots as 4 events. Let us say this is EA0 event. Let us say this is EA1 event. So EA0 event is that event is defined as sending or transmitting symbol 0. EA1 event is representing the event where sending or transmitting symbol 1. Now toward the receiver side, let us again given two events, B0 and B1. B0 is indicating the event where 0 is received, and B1 is indicating the event where 1 is received. Now we have defined the events, these 4 events. Now let us see again, let's come back to the schematic now. Here let me draw 4 lines indicating the transmission and reception. So the first line is here. This line is indicating the transmission of 0 event A0 and reception of 0 event B0. And the second line I am drawing here, this second line is indicating the transmission of 1, that means event A1, and reception of 1, that means event B1. The third line, let me give the third line. So assume this is the third line. Here in this third line, it indicates that event A0 and it is connecting event A0 and event B1. That means this indicating that the 0 is transmitted and 1 is received. So when I say 0 is transmitted and 1 is received, it is simply indicating that error is happened. So similarly, let me draw the fourth line. This fourth line is joining two events. One is the transmission of 1 and reception of 0. Whenever I am saying a 1 is transmitted but 0 is received, it is implying that it is also an error because the transmitted and received symbols are different. Error happened because of something in the channel, something happened in the channel, and that's something we know, that is noise, addition of noise. So here these two straight lines, top and bottom, are correct probabilities, and the other two crossed lines between that straight lines is indicating the error events. So these two are the error events, and the top and bottom lines are indicating the correct probabilities. Earlier we have seen what is symmetricity, the probability of reception of 0 when 1 is transmitted. So this one, if it is given by P, then due to the symmetric nature of the channel, the probability of reception of 1 when 0 is transmitted is also P. Now after this one, let us see what is the probability of the correct transmissions. Correct transmission are actually given by probability of receiving 0 when 0 is transmitted, and probability of receiving 1 when 1 is transmitted. So the top and bottom lines, let us see the probabilities of top and bottom lines. So these top and bottom lines are called the correct probabilities. So now let us see what are the correct probabilities that are indicated by the top and bottom lines, the straight lines that are indicating the correct probabilities. That means, so if reception of B0, let us consider this to be the sample space. Let us consider the sample space as comprising entirely the event, the reception of B0. Now reception of B0 can be happening in two ways. When A naught is given and when A1 is given. So reception of B naught, it could happen when A naught was happened, and also it could happen when A1 was happened. So reception of B naught, if it is the sample space, this can be the probability of B naught, that can be written as P of B naught divided by A naught plus P of B naught divided by A1. And if suppose the reception of B naught is itself taken as the sample space, the reception of B naught, the reception of 0 at the receiver, which is given by the event B naught, if it itself is taken as the sample space, then what we can write is P of S is equal to 1, where S is the sample space, that is simply the event B naught. Here the event B naught is considered as sample space. The reason I will say in the following line. Here we know that P of B naught divided by A naught is actually the correct event. The reception of 0 when 0 is transmitted is actually given by P of B naught divided by A naught, and this probability we have to deduce, we have to obtain this probability, and we also know the probability P of B naught divided by A1, that means the probability of receiving a 0 when 1 is transmitted, or simply the probability of error. For the binary symmetric channel, it is simply P. So now if the event B naught is already happened, so since it is already happened, we can simply take its probability as 1 because it is already happened. Now this 1 is equal to P of B naught could happen when A naught was happened, and B naught could also happen when A1 was happened. This means 0 could be received when 0 was transmitted, and also 0 could be received when 1 was transmitted. And we know this probability, the probability of error when the probability of receiving 0 when 1 was transmitted, and we need this probability, the probability of correct reception, that means receiving 0 when 0 was transmitted. So from this equation, since here the LHS or the probability of B naught is simply taken as 1 because B naught is already happened. So we have taken that B naught is already happened. So its probability is, since it is already happened, we are taking P of B naught as 1. So from this equation we can simply write that P of B naught divided by A naught, the probability of correct reception, is simply 1 minus P. From the LHS equation we can conclude this one. So let's go to next page, and we shall start with the schematic again. So we have seen that the probability of event that is already happened is taken as 1, and that is the sum of probabilities P of B naught divided by A naught plus P of B naught divided by A1. Here we know the probability of error. The probability of error is simply given by reception of 0 when 1 is transmitted, and the correct probability is the reception of 0 when 0 is transmitted. So we know the probability of error. The second term, probability of reception of 0 when 1 is transmitted, it is actually given by P. Now the probability of correct transmission, reception of 0 when 0 is transmitted, is simply given by 1 minus P. From this equation, so let me put equation 1 for this one. So simply the correct probability is obtained as 1 minus P. Here probability of reception is simply 1 because receiving will happen. That means receiving is a certain event. Reception is a certain event. Receiving is happening certainly, but receiving is a certain event, but receiving can be correct reception. Receiving can be error reception. Correct reception is given by probability of b naught divided by a naught when b naught is received. That means correct reception is given when 0 is received and 0 is transmitted. Error reception is p of b naught divided by a1. That means error happens when 1 is transmitted but 0 is received. b naught is received but 1 is transmitted. So here it indicates error reception. So the top one is the correct reception, the bottom one is the correct reception. But reception is a certain event. When a certain event is happened, when reception is happened, it could happen with an error. It could happen in a correct manner without any error. So the probability of this certain event is probability of error event plus probability of correct event. Since it is a certain event, since the reception is certain, we are taking probability of certainty as 1. Probability of error, we have taken it as p, the probability of receiving 0 when 0 is transmitted, when 1 is transmitted, sorry. Probability of b naught divided by a1, this we have taken it as p. And probability of correct event, that means probability of receiving 0 when 0 is transmitted, we need to find it, this one, correct probability. From this equation we get correct event probability as 1 minus p. Since it is a symmetric channel, we have already discussed the nature of symmetricity. Nature of symmetricity is giving us that the probability of reception is symmetric in nature. That means the probability of error is symmetric and also the probability of correct reception is symmetric in both the cases of correct reception of 0 and also correct reception of 1. So this symmetricity indicates that probability of correct reception is equal to 1 by p in both cases, when 0 is transmitted and 0 is received, and also 1 is transmitted and 1 is received. And also this symmetricity is indicating that probability of error reception, that means whenever 0 is received and 1 is transmitted, and also probability of 0 is received and 1 is received and 0 is transmitted, in these cases the error is happening and the probability of this error is same. The probability of 0 is received when 0 is transmitted is 1 minus p. Similarly, due to symmetricity, the probability of 1 is received when 1 is transmitted is 1 by p. Similarly, the probability of 0 is received when 1 is transmitted is p, the probability of error, and also probability of 1 is received when 0 is transmitted is p, the probability of error. So these two probabilities are same and also these two probabilities are same. In such a case, it is called as the symmetric channel. Now let me give you the schematic along with the probabilities. Now this is our transmitter. The left side is indicating our transmitter. The right side is indicating our receiver. Transmitter can only transmit two symbols, one is 0 and one is 1. Receiver also is going to receive only two symbols, one is 0 and one is 1. The transmission of 0 is indicated by the event E0 and the transmission of 1 is indicated by the event E1. The transmission of, the reception of 0 is indicated by the event b0, and a reception of 1 is indicated by the event b1. Now let me draw a line. This line is indicating the reception of 0 when 0 is transmitted, and this line, the other line, is indicating the event 1, reception of 1 when 1 is transmitted. We have reduced the expressions for these probabilities, the correct probabilities, as 1 minus p and 1 minus p in both the cases, since the channel is symmetric. So let me write the probabilities above the arrow 1 minus p. Now I am drawing another two lines indicating another two transmissions. Now this line is indicating that 0 is received but 1 is transmitted. That means here it is indicating it is an error, and earlier we have reduced the expression, the probability for error, as p. So let me indicate the line as error, and also let me indicate the probability as p. Similarly, there is another line. This line is indicating that 1 is received when 0 is transmitted. So let me indicate this one is also with the associated probability that we have already obtained here as p. Since this is symmetric, both the crossed line probabilities are also p, and both the straight lines probabilities are 1 minus p. Now, so this is a completely the binary symmetric channel. Now the analysis will be completely done relating to binary symmetric channel. The complete analysis will be finished only by after obtaining all the probabilities. All the probabilities, let me list them one by one. So the first probability is, let us say, start with the transmitter p of a0. P of a0 is the transmission of probability, the transmission probability of transmission for 0. So let us give it as, since it is a probability from the transmitter side, it is dependent on the actual information that is being transmitted. It is not affected by the channel, because the channel is starting from the right side of the transmitted. Wherever I am writing the channel, writing the longitudinal dotted lines, the channel is actually between these two lines. Whatever the effect of noise is happening, it should happen between these two lines. So before this line, the channel is itself is not yet started. It is only the transmitter side, and the probability of transmission of 0 can be completely dependent upon the transmitted signal. It is not dependent upon the channel. So let us assume a value of like p0 for this. Similarly, there is this other probability, the probability of transmission of 1. It is also dependent upon the information. Let us give the value p1 for this. Now we have already seen the error and correct probabilities. The correct probabilities are reception of 0 when 0 is transmitted, given by p of b0 divided by a0. This is the correct probability that is actually given by the 1 by p. Due to the symmetricity of the channel, p of reception of 1 when 1 is transmitted is also given by 1 minus p. On the other probability, the error probability. Error probability is actually given by reception of 0 when 1 is transmitted. That means it can be indicated by p of b0 divided by a1. It is actually given by p as earlier discussed, and that is same as p of probability of reception of 1 when 0 is transmitted. Due to symmetricity, both these error probabilities are same. So let me put a bracket and indicate that these are the error probabilities, and indicate that these are correct probabilities. Now let's go to the next page. So we'll continue in the next page. So till now we have seen some 4 probabilities. These are the transmission of zero or one probabilities which are given by a naught and p of a1. These are simply indicated by p naught and p1 respectively. The other probabilities that are seen are probability of reception of 0 when 0 is transmitted, probability of reception of 1 when 1 is transmitted, correct probability is 1 minus p, and error probability is 2. P. And a schematic also we have given. Let me take a small schematic here just for the purpose of continuity. These are the correct probabilities which are written on the straight lines, and wrong error probabilities which are written on the crossed lines. This is the transmitters, this is the receiver. There are only two symbols, one is 0, the other one is 1. There are only two symbols toward the receiver side, one is 0, the other one. Noise is only added over the channel. Now let's come back. Now there are now let us go toward the receiver side. Toward the receiver side, what are the probabilities? Let us observe probability of reception of b naught and probability of reception of 1. Probability of reception of 0 is actually given by probability of b naught. The probability of reception of 1 is given by probability of b1. Now we understand that wherever event b naught is happened, that means 0 is received. So 0 could be received when 0 was transmitted, which was given by p of a naught divided by p of b naught divided by a naught, and 0 could be received when 1 was transmitted, which is indicated by p of b naught divided by a1. Now probability of b naught is happening only in two cases: when b naught is received, when a naught is transmitted, and b naught is happened when a1 is transmitted. So b naught is comprising in itself b naught is comprising two smaller events, which are probability of b naught given a naught has happened, probability of b naught given a1 was happened. So I can write this one as, so simply instead of even before going to probabilities, I can write b naught as b naught intersection a naught and b naught intersection a1. So b naught is having intersections with a naught and a1, where b naught happens when a naught has happened, and also b naught could happen when a1 was happened. So the total b naught can be written as p of b naught intersection a naught union with b naught intersection a1, because b naught is comprising of only two events, a naught and a1. Now from this, probability of b naught can be written as probability of b naught intersection a naught union, or we can also write this as plus probability of b naught intersection a1. Now if we go a bit deep here, these probabilities b naught intersection a naught and also b naught intersection a1 are the joint probabilities, and joint probabilities can be written in terms of conditional probabilities. So p of b naught can be written as p of b naught divided by a naught into p of a naught plus p of b naught divided by a1 into p of a1. Using when we have already discussed how to express the joint probability in terms of conditional probabilities, from the expression that gives conditional probability in terms of joint probability. For reference, I shall write it here also. P of a divided by b is equal to p of a intersection b divided by p of a. Just by applying this expression, we have obtained this expression, which I am indicated by the symbol 2 or the number 2. Now we have earlier seen that P of A naught divided by B naught divided by A naught is simply the correct probability, that is 1 minus P, and P of B naught divided by A1 is simply the error probability, that is P. So this is 1 minus P. I'm missing the place here, so let me leave the expression, but I'm indicating P since I am having place here. And P of A naught, earlier we have seen the probability of transmission of 0 as P naught, probability of transmission of 1 as P1, that is completely dependent upon the information, which is not interfered, which is not affected by the noise, because the transmitter is even before the channel where the effect of noise is not yet started. So rewriting the above equation 2, P of B naught can be written as 1 minus P into P naught plus P into P1. Similarly, P of B1 can be written using these terms P, P1 and P naught. Let us see how. B1 can be written as B1 intersection A naught union B1 intersection A1, because B1 is the event that has happened, B1 indicating that received symbol is 1, and 1 can be received when 0 is transmitted, and 1 can be received when 1 is transmitted. 1 can be received only in these two cases. Of course, there are only two cases possible: one 0 is transmission, one is 1 transmission. Now from this expression, B1 can be written as sum of the events B1 intersection A naught and B1 intersection A1. Now if we take the probability on both sides, P of B1 is equal to probability of B1 intersection A naught union becomes plus probability of B1 intersection A1. Similarly, by expressing the joint probabilities in terms of conditional probabilities, we can write it like this. And we have already obtained the expressions for P of B1 divided by A naught. This is the error probability given by P, and P of A naught is actually given by P of P naught, and P of B1 divided by A1 is a correct probability, that is 1 minus P, and P of A1 is simply P1. So P of B1 can be written as P naught plus P1 minus P1. So let us put P of B naught, that is earlierly obtained as P of 3, the third equation, and P of B1 that is obtained now on the same lines. Let us indicate this as the fourth equation. So up till now we have understood how to calculate. We have assumed the probabilities P of A naught and P of A1. Later that we have understood the probabilities, correct probabilities, we have understood the error probabilities, we have understood the receiver probabilities P of B naught and P of B1. Now finally let us understand the conditional probabilities. These two conditional probabilities, we will introduce a different term later which will be correct for these kind of probabilities, but for let me now introduce the calculation of these probabilities, the last two probabilities. These probabilities are probability, let me put because these probabilities calculations are a little bit different from the earlier cases, let me put different symbols for this. The alpha symbol, it is simply probability A naught divided by B naught. The beta one, the second one, probability A naught divided by B1. So let us put the third one as, so let us follow with 1 and 2, no need of further confusion. The third one as probability of A1 divided by B naught. The fourth one as probability of A1 divided by B1. So now let me introduce the correct term that is used for these probabilities. We observe here P of A naught divided by B naught, it is indicating that B naught is already happened, that means 0 is already received, but we are going to calculate the probability of transmission of 0. Probability of transmission of 0 given the probability given that 0 is actually received. Given that 0 is actually received, such a probability is called as a posteriori probability. This is the term used for such a probabilities. Whenever A is in the numerator, that means transmission is in the numerator, and B is in the denominator, that means reception is in the denominator. Such a probability is called as a posteriori probability. The reason is that a posteriori indicates the meaning of this word a posteriori is after the fact. After the fact means after the reception has already happened. After, that means the event after B0 is happened, after B1 is happened. B0 and B1 are simply indicating the reception. So after the reception has happened, we are calculating the probabilities of transmissions. So we are calculating the probabilities of transmissions A after the reception has already happened. That means after the happening of B, we are calculating the probabilities of A. So such a probabilities are which are calculated after the events after the reception has happened is called as a posteriori probabilities. The term is important, which will be used later in various communication systems. A posteriori probabilities. So now let us see the calculation of each of these terms. Now once we calculated the first term, we are automatically understanding how to calculate the other three terms. So let's go to the next page now. So now let us calculate. So let us start with the first one, P of A0 divided by B0. Here we are already indicating that event is already happened. And what event is already happened? Reception of B0. I mean reception of 0, the event B0. It is already happened. 0 is received. Now we need to calculate what is the probability of transmission of 0. So when 0 is received. So here we are already told that 0 is received. Now we need to calculate what is the probability of transmission of 0 when 0 is received. So this is called as a posteriori probability because a posteriori the word, because the event is already happened. What is the event? The event is B0, reception of 0. It is already happened. Now we need to calculate the probability of transmission of 0 when 0 is actually received. So this one, a calculation is not straightforward. We need to use Bayes theorem in order to calculate this probability. Here Bayes theorem is applied. Bayes theorem in the last class we have already discussed. Let me put it in a simple statement here again. Bayes theorem. Bayes theorem is, let A and B are two events. P of A by B can be expressed using P of B by A using Bayes theorem. That is given by P of A by B is equal to P of B by A into P of A whole divided by P of B. This is a Bayes theorem and it is intuitive also, because a P of B by A we can be written as P of B intersection A whole divided by P of A. So if P of B by A is simply replaced by this expression, this could be replaced by this expression from the definition of the conditional probability, P of B intersection A divided by P of A into P of A whole divided by P of B. So P of A and P of A will be cancelled. Simply that is P of B intersection A, P of divided by P of B. So that is the definition of the conditional probability that we have already seen earlier. So Bayes' theorem is not a completely different one. Bayes' theorem is itself the statement of the conditional probability itself, but expressed a little in a little bit different manner. That means here overall Bayes' theorem is taking the form that means expressing one conditional probability in terms of the reverse conditional probability. So this statement, the first part of this big equation, this statement which is inside the box is the Bayes' theorem and Bayes' theorem's statement, and this is nothing but expression of conditional probability itself in terms of the reverse conditional probability. P of A by B is equal to P of B by A into P of A divided by P of B. So now let us apply the Bayes' theorem in order to determine our a posteriori probability P of A naught divided by B naught. So from the Bayes' theorem we can simply say P of B naught divided by A naught into P of A naught whole divided by P of B naught. Yeah, but from the previous page, if we remember, we yesterday, not yesterday, in the previous page, we have deduced the expression for P of B naught using the total probability and P of A naught and also P of B naught divided by A naught. So probability of P of B naught divided by A naught is a correct probability, that is 1 by P. P of A naught is assumed to be P naught, and P of B naught we have deduced in the previous page. So once let's go to the previous page and have a look at that. So here P of B naught, the third equation is P of B naught, that is actually given by 1 minus P into P naught plus PP1. 1 minus P into P naught plus PP1. 1 minus P into P naught plus PP1. So this is the probability of B naught. So this can be written as P naught minus PP naught, simply expanding the brackets, divided by P naught minus PP naught plus PP1. So this is simply given by P of A naught divided by B naught. The a posteriori probability is solved and the resultant expression is P naught minus PP naught divided by P naught minus PP naught plus PP1. So now let me solve another a posteriori probability for having some more insight. Let us solve the second one, P of A naught divided by B1. Here let me define this probability. This is a conditional probability which indicates the reception of, so let me put it in the words, this is the probability of a reception of, so it is a probability of not reception, it is actually the probability of transmission. Let me change it a little bit. It's the probability of transmission of 0 when 1 is received. Here the probability of 1 is received, already received, that means this event is already happened is coming in the denominator. Here this conditional probability is indicating the probability of occurrence of A naught when B1 is already happened. B1 is the reception of 1, so 1 is already happened, and the probability of transmission of 0 when 1 is already received is actually given by P of A naught divided by B1. It is a posteriori. The reason is that this probability is being calculated after 1 is received. That means this probability is calculated after the reception is happened. This probability is calculated after the event is happened for some condition that happened before, after the result is obtained. Such a probability is called as a posteriori. So now let's go deep. Let's find the expression for this a posteriori probability P of A naught divided by B1. So let's go and apply our Bayes theorem. Bayes theorem, so let me state once more regarding this Bayes theorem. Just in the upper part of the slide there is this statement of the Bayes theorem. Bayes theorem is useful when you wanted to calculate the conditional probability of, say, A by B, if you are already having the conditional probability B by A. Using the conditional probability B by A, if you wanted to calculate the conditional probability A by B, then go for Bayes theorem. So now let us calculate P of A0 divided by B1. The second a posteriori probability. Let's apply the Bayes theorem, or we may simply say Bayes expression. The expression one conditional probability in terms of the reverse conditional probability. So applying the Bayes theorem, we are simply getting P1 B of D1 divided by A0 into P of A0 whole divided by P of B1. So P of B1 divided by A0, that means the probability of reception of 1 when 0 was transmitted is simply the probability of error, which we have concluded many times as P earlier. And P of A0 is simply the probability of transmission of 0, that is simply the probability of transmission of 0 is simply given by P0 whole divided by P of B1. P of B1 I think we have already calculated in the previous page or even in the same page. Let us see. Let's go to the previous slide. So in the previous slide we have obtained the P of B1 at equation number 4. So P of B1 at equation number 4 is PP0 plus P1 minus PP1. So PP0 plus P1 minus PP1, PP0 plus P1 minus PP1. This is actually P of B1. So a posteriori probability P of A0 divided by B1 is actually given by P0 divided by PP0 plus P1 minus PP1, where P is the error probability, P is the error probability, P0 is the transmission of 0 toward the transmitter side, P1 is the transmitter of 1 toward the transmitter side. Now the other two a posteriori probabilities are, the third one is P of A1 divided by B0. Similarly, the other one is P of A1 divided by B1. So if we are considering P of A1 divided by B0, again using the Bayes theorem, you can write this one as P of B0 divided by A1 into P of A1 whole divided by P of B0. P of B0 is, we already know here, P of B0 is P0 minus PP0 plus PP1 from the earlier slide. P of B0 divided by A1 is the errors probability, simply P. P of A1 is simply P, the transmission of one probability, that is P1. Simply the posteriori for the probability is P of A1 divided by B1. So let me define P of A1 divided by B1. P of A1 divided by B1 is a conditional probability that gives the probability of transmission of 1 given 1 is received. This is a posteriori because this probability is being calculated after reception of 1. That means this probability is being calculated after the event is happened, and using the Bayes theorem we can write it as P of A1 divided by B1 as P of B1 divided by A1 into P of A1 and whole divided by P of B1. So again, P of B1 divided by A1 is actually the correct probability, that is simply 1 minus P. P of A1 is P1, that probability of transmission of 1, and P of B1 is simply the probability of reception of 1, that is earlier calculated as PP0 plus P1 minus PP1. So this P of B1 earlier we have calculated using the total probability. That means B1 was written as B1 intersection A0 plus B1 intersection A1, and we have taken the probabilities on both sides, where P of B1 can be will be given as probability of b1 intersection a0 plus probability of b1 intersection a1, and b probability of b1 intersection a0 and probability of b1 intersection a1 are finally found using the conditional probabilities. In the earlier slide itself we have analyzed that one, so let's go back there once and let us have a look at that one, calculation of p of b1 and p of b0. So here, using the conditional probabilities, p of b1 intersection a0 can be written as p of b1 divided by a0 into p of a0. Similarly, p of b1 intersection a1 is written as p of b1 divided by e1 into p of a1. So again, after substituting these values, we have finally obtained the final probabilities p of b1 and p of b0. So finally, let's come to the last page. So this way we have also found the 4 a posteriori probabilities. So let us conclude the concept of binary symmetric channel here. So overall, let me recap once. So in this box, let me write the flow which we have followed in calculation of various probabilities that are related to binary symmetric channel. We have given the schematic of the binary symmetric channel. We have assumed the probabilities of transmissions. As P0 and P1. We have assumed the channel is symmetric. That gives the probability of error as P and probability of correct transmission as 1 minus P. So two lines are having the probability as P and two transmissions are having the probability of 1 minus P. Then we have calculated the probability of B0, the probability of reception of 0 and probability of reception of 1, P of B1, using total probabilities. And then we have calculated the 4 a posteriori probabilities. Probability of reception of 0, the probability of transmission of 0 when 0 was received, probability of transmission of 0 when 1 was received, probability of transmission of 1 when 0 was received, probability of transmission of 1 when 1 was received. These 4 a posteriori probabilities also we have calculated using Bayes' theorem. So let us conclude our discussion about the binary symmetric channel with this, and in the next class we will go further into various distributions, probability distributions, and a further analysis of probability concepts, which will be helping us to study further about the communication systems, especially the nice part of communication systems. Thank you, friends.